more lathe stuff. Now, quite a lot has happened, but not very much has been done, and I'll try to explain that. If you can see the lathe just there, here we are here, you'll see the lathe is turned round and I've got the back opened, and I'll show you around the insides there with a bit of detail, and then we'll get to what I've been doing, which is a little and a lot, but anyway, we'll get to that. I'll lift my wee camera here and you can go round with me. So if I go round here, now you can see all the insides of the lathe here. This is all mid-90s electronics, so the boards are quite large for what they do. I mean, pretty much all of this those, for example, the Chinese little CNC routers you see, all of that would be on a little board about 10 centimeters by 115 centimeters, less even. So I'll take you through it. Okay, so you have your main contactors here, and all your mains coming in here. You have a very nice quality toroidal transformer there. This board here, which you've seen before because I repaired this board, we replaced this transformer. This is the speed controller for the spindle. Okay, now if we go over here on this side here, this is the CPU board for the CNC. Okay, this board here is the I/O, and this board here is the controllers for the two stepper motors. And why I'm in here is down to the other side round here. If I come round, you will see there is a key switch. And just let me put the key in. There. So that key switch is supposed to allow me to operate the lathe with this cover open. Now, if the cover is, I'll just bring my camera around here and set it down. And of course everything is in my way. There we go. This switch here is the interlock switch for the cover for the lathe. Okay, and when it opens, if I can go down there, this bit's on the door, this bit here is on the lathe, so that will open and close. Right, now if you look in there, beside the black winged thing, there are two red LEDs. You probably can't see it because it's they're very small. But if I open this, you'll see one of those red LEDs lights up. Okay, and that shuts down the machine, and you can also hear one of the relays over here as well. So we'll put that back there, and we'll put this back in, and that does that. So the little red LED is off and the relay will have moved back in. So if we come back around here, and I'll move you down to the center a bit, try and get us in shot. I'm going to go round and operate the key switch, and you want to be looking, where's my little arm's gone? Ah, help, 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 I've lost my arm. You want to be looking at that LED there. So if I operate the key switch, you'll see that LED comes on, and I'm hoping you can see it in the display. So I know the key switch is working, but the controller board and the software which is on the screen over there completely ignores it. If I once again pull this contactor switch out, you'd see the red LED lights up, the relay cuts out, and it does exactly the same thing whether the key switch is on or off. Now, there are a couple of things the software says if you turn the key switch you should be able to open the lathe, blah blah blah. It's to allow you to set up tools and things like that, and date them things and set centers and whatever. Anyway, none of that is relevant. But the software ignores that. There's no indication that the key switch has been turned or anything like that. It just ignores it. The other thing is, when you power the lathe up for the first time, if the mains has been completely off, the software is supposed to prompt you to datum the axes. It's not doing that either. So there is some difference in here between the version of the manual I have and the version of the hardware I have. I'd also point out that this appears, this little box over here in your top left where you can see, it has a little sounder on it. It has 3 little LEDs, and it appears to be linked to our key switch over there and our emergency stop. They're all on the same circuit. If I pull my key switch again, you'll see those LEDs flash on this thing here. I don't know if that's very visible, but it's just an LED flash. What this actually does, I don't know. And I'm not going to reverse engineer this thing. It's entirely possible that this LED, there is it's either an IC or a jumper block missing from here. It's entirely possible that this this input signal goes through this. I don't know. I don't need to know. We can leave it as it is, and it's not going to make a huge amount of difference to the operation, blah blah blah. I'm going to forget about it. I've got better things to do. However, forgotten what I was going to say there. Yeah, other than that, no, forget the however, it doesn't mean anything. I don't need to do anything else in here. Everything is working. Basically, this was all full of dust. I've cleaned it all out. These relays, the contacts were dirty on them. They've all been cleaned out. They're working. Everything is working very reliably now. The sticky pads have gone on the. If I bring this up here. Oh, wrong way. Woo-hoo. The sticky pads have gone on the cable, on the cable tie pillar or post things, whatever. Cable tie pads. Not worried. Couldn't give a monkeys. So I'll come back to my camera here, which has gone to sleep on me. All of the electronics work well. All of the, to my knowledge, mechanically and electronically, the lathe now is 100%. So what I'll do is I will bolt it all back together, and I will turn it round to its normal location, and we'll have a look at some of the other things that I've been doing. So if you want to give me a few minutes, I'll do that and I'll get back to you. I forgot a bit. We'll go back here. There are a few mechanical things have been done as well, so we're not worried about this anymore. We can let that go. I have here the nuts were out of there, or the nuts or riv nut, whatever you want to call it, had loosened, and you couldn't screw the back screw into that anymore. I know for a fact, if you look here, this has been dropped, and this was out of shape here. This whole cabinet had sort of been pushed to the left and down. You can actually see the damage here, and this panel is pushed in slightly. That isn't a problem, but everything had been knocked out of kilter a wee bit, so I've pulled everything back and hit things with hammers and what have you where necessary. So that riv nut was replaced, and if we look underneath, you'll see there and there there were also riv nuts, and this is the case that covers the motor and the spindle, and those have been replaced as well, and all of these tabs have been straightened up, so the whole thing lines up a lot better now. And mechanically it's all fairly sound. So anyway, look, let me put it back together, swing it round, and we'll take it from there. Right, we're back again. I've turned the lathe around so you can see everything there. The software's up and running and it's recording on that screen. What you're seeing on my keyboard is recording on this screen here, and I've got my little handheld camera, so hopefully you'll be able to see what we're doing here. So the first thing we need to do, when you switch the lathe on, you run the software, you log in, and it gives you the screen that I'm showing you on my little camera, plus hopefully you've got a recording of that as well. And then we go into this screen, and if you see in the top right, that says machine control. So that means if we go to the menu, we'll see that the machine is on. So the lathe is on and the software is talking to the lathe. Okay, so the first thing we need to do is the lathe needs to know where it is. So we've been through this before. There's a little micro switch there which deals with the x-axis, and there's a little micro switch there which deals with the z-axis. And if we go to here on the software and datum x-axis, I'll bring this around so you can see it. Okay, the lathe knows where that tool head is, okay, in the x-axis. Now if we do Z, you'll see it'll come this way. And it now knows where it is in the z-axis. Now, if we look at the screen, I'll put the screen down in the bottom left hand corner so as you can see it there. If you look at the X and Y coordinates, you'll see they're a bit silly because it just says 40X and 20Z. Okay, now if I don't want to move anything very far, so if you press F5 on the keyboard, which is there obviously, you'll see that here you'll see the jog changes. So we've got continuous, jog millimeter, jog 1/10 of a millimeter, jog 0.01 of a millimeter, or 10 microns. Okay, so we'll just put it back to 1. Now, here's an annoying thing about the software. The software, as you can see, even though you've got lights reflecting of it, it's got X and Z buttons. But if I try and press one of those, it gives me wrong operation, use the machine keys to move. So to actually move the slides, you have to use the buttons here. So I'll just move Z, that's moved to millimeter, and X, that's moved to millimeter. And you'll see now that the X and Z and the software screen have now updated to where they actually are. Okay, so the refresh for the, effectively it's DRO, the refresh here is terrible. Well, it's not terrible, it does work, but it works most of the time, and then there's sometimes it just doesn't work, which is a bit of a pain in the arse. Anyway, we'll go back here. So now in the background I have been doing things, and things I have been doing have been setting the offsets for the tools. Now this is tool number 0. Now if we go back to the software menu here, go to settings and go down to the next page, you'll see, there you go with the blue highlight, there's a roughing tool, a finishing tool, a grooving tool and parting tool, which are the same tool, and a threading tool. Okay, and then you have tool change on X and tool change on Z, and I've no idea what that does. I would have thought that when you tell the machine you want to change a tool, it moves it to a safe position, but it does nothing. So the roughing tool, which is this one, is tool 0. Then we have the finishing tool, which is tool 1, the grooving and the parting tool, which is tool 4, and the threading tool, which is tool 5. You can see all the wee different tips on those. I also have a boring bar. Now I haven't bothered with a boring bar offset because it's actually much easier to do a datum for that tool itself when you're about to use it, because beforehand you'll have had to drill a hole. You need a 12mm hole drilled before you can use this. So you're moving things about all over the place, and you're moving the cross slide out of the way to get the tail stock in, and blah blah blah. So what I have done is, all of these tools I have now set the offsets, so I can put a tool in the quick release here, and if I go to the software and go and tell the tool head to move to a specific location, I'll use 1mm here. So if we type in a Z value of 1 and hit enter, now that's going fairly slowly because the feed speed's at a slow speed. Okay, and that has moved, and it will stop in a moment. Okay, now if I then do a move on X, and on X I don't want to go to 0 because 0 is actually the center there. Basically I want to go to this corner. So if I go to 20, This is a 25.4, so if I go to 26.4, it should be at the corner of this, a millimeter from the corner of that. So type in X, 26.4, and now if I can get you in so as you can see this, you'll see that that's pretty much at 1-1 from the corner of the workpiece. Hard to say, but look, believe me, it's in the right place. So I have now set that for all the tools, so I can happily turn something on this, go to the parting tool, take it off, put this tool back in, and it knows where everything is. It has to be said now, that only works if you've got a billet of a specific size, or if the size of your billet doesn't change, right? If I put a different billet in, then I have to zero this again. And I have to go, yes, do a facing cut, that's 0 on the Z, and come in and do a shoulder cut, then that's my 0, or whatever width it is on my X. But once you've set that for one tool, then that's set for all the tools, because the offsets are recorded. So that makes life a bit easier. I still have to do some turning to find out how accurate all that is, and if I need to adjust my measurement and all that sort of thing. Anyway, the other thing we've worked out is if I come back away from the workpiece there, because I don't want to actually machine anything here. So if we go, move on Z, TED. We've also worked out all the various keyboard shortcuts that you need to operate the machine. Now, obviously, we've already found out that to move this slide, you need to use this control panel. So Z minus Z plus, X minus X plus, and you've got a high speed button there as well. I had to replace that button because that button was faulty. Tell a lie, it was the Z minus was faulty, but I took this button, put it there, and put a new button in there because it looks nice. Anyway, there you go. If I start the spindle, which is Alt 1, you can see that goes there. And if I rest my camera here, I'll just hold my camera. And if you look at the keyboard camera, if I press F for faster, that brings the speed up of the spindle. So there we are, up to 600 RPM. Let's see if I can go to, if I go S for slow. Oh, we're nearly there. See if we can get it to look like it's going backwards. There we go. That's at 540 RPM. So S makes that slower. Okay. Happy days. If we want to stop the spindle, it's Alt 3. So we've got spindle control on keyboard shortcuts down here. The other shortcuts that we have down here are If we hit Z, it will allow us to zero the Z. If we hit X, it will allow us to zero, or actually set the position of the X-axis, because you might be bringing that up to the shoulder of a piece of a known size to do that. We also have, over on the numeric keypad, plus increases the feed rate and minus decreases the feed rate. So all the things we need to control, more or less, we can control from the keyboard. There is one thing that we can't do from the keyboard, and I have yet to find a way. I can't send, well, you can't send G codes directly to the machine. You have to write a program that will send the G codes. So for example, if I want to go to a specific set of coordinates, I have to go to the menu, go machine, move on Z, type in the value. That goes ahead and does that. And likewise for the X-axis, machine, move on X, 40, and that does that. What I can do is, and what I am going to do is, I can remap my F11 and my F12 to basically do a series of keystrokes. So for example, if I press escape, which will clear out the command buffer, and Alt M, which will open the machine menu, and down arrow 1, 2, 3, 4, and send and enter, I can then enter a figure and we can do it that way. So what I'm going to do is put macros on those two keys that will allow me to just hit a button to enter those commands. It would be nice if I could find ways of controlling the X and Y from the keyboard, because then I'd only have one set of controls to work at. But what I'm going to do for the time being is basically take all this gubbins here and move it over to this side, and have my keyboard up here where I have my tools at the moment, and have my screen there. I can mount a Visa mount on the side of this panel here. So now if I go back here, and my screen's gone off on my camera. I wonder, can I switch it on again? Don't know. Oh, there we go. So now I can see. The mechanically and electronically and software wise, the lathe is now working fine. It's executing programs and it's doing everything that it's supposed to do. It's working well. I mean, I've actually made some pieces with it and used you know, that I need, that I actually had a use for. But anyway, that's by the by. The question now is, what's the way forward for the lathe? Because of its age, because this is basically 30 years old, it's 31 years old, based on the dates of the ROMs and things like that. It's very limited. The hardware, the actual steppers and the spindle and the bed and the end stock and the cross slides and all that, they're all perfect. There's nothing wrong with them. It's actually the software and the electronics that lets it down. And what I'm considering is basically upgrading the electronics to modern electronics, because you can buy a controller board that will run all. In fact, you can buy a controller board and stepper motors and the motor drivers for about 100 quid from China. and it will do everything that it does at the moment, but I'd be able to use modern software like Mach 3 or something with it. I mean, for example, at the moment, if I just want to say machine a sleeve, it's actually quicker to write the program in. Well, I use LibreOffice, so Sheets, rather than type it out longhand in the software here. And the graphical design software in this, I haven't really got my head around it yet. I can actually show you it here. If we go into, is it this? Yes, there it is there. So for example, if I want to insert an arc, insert that to the right, there's my arc, so I can do that. As I say, I haven't got my head around this yet, I don't know how it works. Diameter too big, don't know. But there's an arc there, and then I've got a collar here, or cylinder here. I don't know how. We'll have to escape out of that. So if I make my cylinder, no, there. Cylinder profile, there's my cylinder. So if I go to my arc, can't even select my arc. Anyway, this is a pain in the arse. So I need to work out how this all works. I'll go back here now. So I would say this will probably be the last video for the lathe for a while. There are other things I need to get back to. But we'll park the lathe for now because it's operational now. I may actually, if I have something interesting I need to turn, I'll take a video of that. But the lathe works, the lathe's operational, it's fixed. It's a CNC lathe that cost me buttons, and it works very well, and I've got all the tools that I'd ever need and things like that. So we'll leave that for now. We'll talk to you all soon, and in the meantime, don't do anything stupid. Talk to you soon.